Hello everyone. Today is the sixth lecture of our data science course, and today we are going to discuss about naive-bayes classification. So firstly, we'll talk about understanding the naive-bayes theorem. What is the naive-bayes theorem? So for understanding this, first we have to learn about Bayes theorem. So what is Bayes theorem? The naive-Bayes algorithm relies on the fundamental Bayes theorem to calculate the probability of a hypothesis given the available evidence. Means it is similar to the Bayes theorem, in which we calculate the probability using the hypothesis testings like z-test, f-test, etc. test. Second, it provides an independence assumptions. So naive Bayes assume that the features are independent of each other, which simplifies the calculations but may not always hold true in real world scenarios. Thirdly, we have the probability estimation in the naive Bayes theorem. So the algorithm estimates the prior and conditional probability from the training data to make predictions or new unrevealing data. Means using the conditional probability things, we can predict the data, we can predict different things using naive-Bayes theorem. So now we'll talk about the data pre-processing and feature selection in the naive-Bayes theorem. First, we have the data cleaning. Uh, in this, we can ensure the data is free of missing values, outlines, and noise is crucial for the accuracy of the naive-Bayes model. Secondly, we can ensure the feature of engineering by selecting and transforming the right features can significantly improve the model's performance by capturing the most relevant information. So, by doing the correct engineering or using the correct engineering features, we can implement the naive-Bayes theorem and make our data or model very specific or very accurate, very predictive, uh, where user can get their results easily, their outputs easily. Thirdly, we can do feature selection, so identifying the most informative features and removing irrelevant and redundant ones can optimize the naive-Bayes algorithm. Means we can remove the irrelevant parts in the data and make it more shorter, which does the same task as the larger one. So this makes our data more relevant, and we can do it by using the naive-Bayes algorithms. Now we'll talk about how we can build a naive-Bayes classifier in R language or Python language. So here's an example in the R language. You can see on the picture. Here's the example in R language to build a naive-Bayes classifier. So first, we can do it by date. So for doing it, our first step is data loading. So in data loading, we load the data set into programming environment such as R or Python for further pre-processing or processing. Means we load it in programming environments like in a programming language, and we can generate the output, and then we can do our further pre-processing on the models. Secondly, do the model training. We'll fit the naive-Bayes model to the training data, estimating the necessary probabilities for classification. Means we'll train the data for predictions necessary for each and every probability, yes or no. Means if we have yes, then it is ready, the data of that is ready, and if we have no, for that also we have the data ready. Thirdly, the last step is the model evaluation. So we assess the model performance using appropriate evaluation matrices such as accuracy, precision, recall, and if-when processes, as we have discussed earlier in the lectures. Uh, so by using the accuracy, improving the accuracy, precision, uh, improving the recalls, and improving the F1 score, we can make the model or data more appropriate for the user. Now we'll talk about the model evaluation and practical applications. So firstly, we have the performance matrices. So evaluating the naive-Bayes model's effectiveness using various performance matrices to ensure it meets the project's requirement. Secondly, we have the real-world applications of it. Naive Bayes is widely used in spam detection, text classification, sentiment analysis, and medical diagnosis due to its simplicity and efficiency. Thirdly, we have the model limitations. The independence assumptions of naive Bayes may not always be true, which can limit its performance in certain problems uh, do do in the world. So we have the independent assumptions in the naive Bayes, which are not always true. So but mostly it helps. So we can use the naive Bayes classification. Thank you for this lecture. We'll talk about more topics in the next lecture. Thank you.